Hi everyone, today we're going to talk about comparing linear functions. So in previous lessons we looked at how to interpret linear functions, and so we're still going to be doing that today, but now we're going to be looking at two different linear functions and not only interpreting them but comparing them as well. So if you look at example 1, it says a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of the zebra. Compare their speeds. Okay, so we're told that the lion runs at a speed of 53 feet per second. So feet per second implies a rate of change, which means if we were to look at a graph of the lion's speed, we would see that the slope is 53. And so when we're looking at the graph, which is the speed of the zebra, we want to also find the slope so that we can compare the speeds. Okay, so one way we can do this, given a graph, is we can count the rise over run, which in this case it's not as easy to do that because the points that we're given are really not nice points to count rise over run. And so I would recommend we use the slope formula. So just as a refresher, the slope formula is y2 minus y1 over x2 minus x1. And what I need in order to use that formula is 2 points from the graph. So I'm going to choose to use the point 2, 118, and 4, 236. Okay, so I'm going to treat my first point as this one, and this one will be my second point. So when I plug this information into my slope formula, it's going to look like 236 minus 118, that's my difference in my y's, and on the bottom here is the difference in my x's, which is 4 minus 2. So if I simplify this, I get 118 over 2, which means that my slope is 59. And so for a zebra, we know that its speed is 59 feet per second. And so we need to say something that compares their speeds, and so it can be something as simple as zebras can run faster than lions. Okay, so we've compared the two. Number 2. The number of new movies a store receives can be represented by the function m equals 7w plus 2, where m represents the number of movies and w represents the number of weeks. The number of games the same store receives is shown in the table. Okay, so we're talking about a store that is receiving movies and games each week. And so what we're going to be doing is we're going to be comparing the movies versus the games that the store receives. So a couple of things to point out. This is probably the first time we've looked at an equation that doesn't use x and y. Okay, so it's important to notice that the m, because that's in the place where y usually is, means that the movies in this case is y. Okay, and the w is where the x usually is, so weeks in this case is our x. Okay, so that'll be important when we're trying to figure out our slope and our y-intercept so that we can write the equation. So part A says to write an equation to represent the number of games the store gets in a week. So we can get the information we need from the table. So just to remind us, I'm going to put that x is technically weeks and y in this case is the number of games. Okay, we're going to use w and g in our equation, however, just so that we're remaining consistent with how they wrote their original equation about movies. Okay, so to write the equation, we need two things. We need the slope and we need the y-intercept. So given a table, we can usually find the slope by looking for the change in y and the change in x. So if I look at my change in y, I'm going from 15 to 24. That's adding 9. And then from 24 to 33, I'm also adding 9. Okay, and if I look at my change in x from 5 to 8, I'm adding 3, and from 8 to 11, I'm adding 3. So my slope is change in y, 9, over change in x, which is 3. And 9 over 3 is 3. So I'm kind of halfway there with having my equation because I know the slope. Now what I don't know is my y-intercept. Okay, so what I could do here is use my slope-intercept form, and I could plug in one of the points from the table and the slope that I just found and solve for b. So why don't we do that? So I'm going to just pick the point 5, 15 from the table, just the first one that I see there. And so I'm going to plug into my equation 15 for y, because that's the y coordinate of the point I chose, 3 for m, that's my slope that we figured out. The x coordinate of that point is 5, and b is what I don't know. That's what I'm trying to figure out. So this is going to be 15 equals 15 plus b. Just going to write this here. So to solve for b, I have to subtract 15 from both sides, which gives me a b of 0. So when I write my equation, it's going to be, remember, instead of y equals, we're using g for gains. So the number of gains equals my slope, which is 3, and instead of x, we're using w. And we could put plus 0 since the y-intercept was 0, but we don't need it. So we can just leave it as g equals 3w. Okay, so part B says compare the initial values. So remember, initial value is the same as the y-intercept, the b. So for the number of movies, we have the b is 2. Let's put here movies. And for games, our b was 0. So what does that mean? What does the y-intercept mean in the context of the problem? Well, it means that at week 0, the store had 2 movies and 0 games. So one way we can state a comparison is to say that the store started with more movies than games. So the store started with more movies than games. Okay, to compare the rates of change. So remember, rate of change is the same as slope, which is our m. So for movies, if I go back up to my equation, my m, or my slope, was 7. And for games, we found that the slope was 3. So in the context of the problem, this means that the store was receiving 7 movies per week and 3 games per week. So a statement to compare these could be the store receives more movies per week than games. Okay, the last part here, how many new movies and games will the store have in week 6? Alright, so in order to figure this out, we're going to use our equations that were given. So remember, the equation that they gave me for movies was m equals 7w plus 2. And the equation that we figured out for games was games equals 3w. And so to figure out how many new movies and games the store is going to have in week 6, I'm going to use 6 as my value for w in each of the equations. So for movies, we're going to substitute 6 for w. And we're going to get that at 6 weeks, the store is going to have 44 movies. For games, again, substitute 6 for W, and we're going to get that after 6 weeks, the store will have 18 games. So that's how we use our equation to figure out different values. Okay, for number 3, the function m equals 140h, where m is the miles traveled in h hours, represents the speed of the first Japanese high-speed train. The speed of a high-speed train operating today in China is shown in the table. Assume the relationship between the two quantities is linear. Okay, so we're given the equation for the Japanese train. Looks like that. And what we're being asked to find is the equation for the Chinese train. And we're going to use the table to get that information. So again, we need two things. We need the slope and the y-intercept in order to write an equation. And so let's figure out here first which variable is x and which variable is y. So based on the equation that we're given for the Japanese train, we can see that they're using m, which is miles, for y. So right away in my chart here, my table, I'm going to put y for miles. And then h is where x would normally be, which means hours is going to be our x. So to find our slope, remember we're doing change in y over change in x. So let's see how y changes. So each time here, I am adding 217 to get to the next number. And the way I figured that out was I subtracted 651 minus 434 and I got 217. Then I did 868 minus 651 and I got 217, and so on. So that's how I was figuring out the change. And then on the other side, this one's easy, it's going up by 1 every time. So my slope is 217 over 1, which is just 217. So I'm halfway there. I have the slope. Now, to figure out my y-intercept, what we could do is a trick I showed you in the previous lesson where we kind of work backwards on our table. And so what I'm going to do is I'm going to think, okay, if I go back to 1 hour, that would mean I have to subtract 217, which actually 434 minus 217 is 217. And then I'd have to go back 1 more hour to get my y-intercept, because it's always when x is 0. And so 217 minus 217 is 0. So that means that my y-intercept of this equation is 0. All right, so we're ready to write our equation. Now instead of writing y equals 217x, we're going to use the variables that they used in the other equation. So in this case, y is miles, which they're using m, not to be confused with slope. So m equals our slope, 217, and instead of x, they're using h for hours. Okay, so that's the equation of the Chinese train. Now it says to compare the initial values. Well, the initial value of the Japanese train was 0. And the initial value of the Chinese train was also 0. So we can say, obviously, that they're the same, but in the context of the problem, what does that mean? It means that at hour 0, they've traveled 0 miles. Well, that makes sense, doesn't it? Both trains traveled 0 miles in 0 hours. So it seems pretty obvious. If they haven't traveled for any amount of time, then they haven't traveled any mileage. So comparing the rates of change. Okay, so the rate of change for the Japanese train was 140. For the Chinese train, we found that it was 217. So remember, the rate of change in this situation is how many miles per hour are they traveling? And so we can say the Chinese train travels faster than the Japanese train. The Chinese train travels at 217 miles per hour, where the Japanese train only travels at 140 miles per hour. So the Chinese train travels faster than the Japanese train. Okay, part D. If you ride each train for 5 hours, how far will you travel on each? Alright, so here we go. Let's use our two equations to figure this out. So the Japanese train had an equation of m equals 140h, and the Chinese train we found was m equals 217h. So if we're traveling for 5 hours, that means that I'm substituting 5 in place of h. So for the Japanese train, 140 times 5 gives me 700 miles. So if I'm on the Japanese train, I would go 700 miles in 5 hours. If I'm on the Chinese train, 217 times 5 gives me 1,085 miles. Okay, so there's how far you would get on each of them. And actually, I could have gotten that information from my table. Right here it says after 5 hours, I would have gone 1,085 miles. Okay. All right, number 4. Nick and Vicky each have a monthly cell phone bill. Vicky's monthly cell phone bill is represented by the function y equals 0.15x plus 49, where x represents the minutes and y represents the cost. Nick's monthly cost is shown on the graph he made. Okay, so we have two different people here comparing their monthly cell phone bill. So we know that Vicky's bill is represented by that equation, and then we have Nick over in the graph here. So I'm just going to label those to keep them straight. And so they're asking us to write an equation to represent Nick's bill. Okay, so again, we need the slope and the y-intercept to write the equation of that line. And so I would recommend looking at your slope formula to figure out your slope for this. So m equals y2 minus y1 over x2 minus x1. And I would just pick any 2 points. I'm going to pick the first 2 points to use. So I'm going to call this x1, y1, and this x2, y2. And so when I plug that into my slope formula, I'm getting 72 minus 60 as my difference in my y's, and 120 minus 0 is the difference in my x's. So that gives me 12 over 120, which makes a slope of, as a decimal, 0.10. Okay? And the reason I'm writing it as a decimal, normally I say, leave your slope as a fraction. I'm saying to leave it as a decimal in this case because in the other equation for Vicky, they left it as a decimal, and the reason is because it's money. So it's okay to have a decimal for a slope when you're talking about money. Okay, now the other thing we need is the y-intercept, and thankfully we can get the y-intercept right from the graph. They tell us the point 060 is on the graph, and anytime x is 0, that is your y-intercept. So we can say b is 60. So the equation for Nick's line is y equals 0.10x plus 60. We found the 2 pieces we need. Okay, so part B says to compare the initial values. So Vicky's initial values, or initial value I should say, is 49. So I got that right from her equation. And Nick has an initial value we just found of 60. Okay, so what does this mean? What does it mean that when you have used your cell phone for 0 minutes, that you're still paying $49 if you're Vicky and $60 if you're Nick? Well, it means that that is your initial fee on your plan. So no matter what, you're paying that amount of money up front before you even start using minutes on your phone. Okay, so I'm going to say to compare them, Nick's monthly So Nick pays $60 up front for his monthly fee, and then in addition to that, he pays per minute, where Vicky pays $49 as her initial monthly fee, and then her minutes get added onto that. Okay, so part C says compare the rates of change. So again, let's look at their equation. So Vicky's rate of change, which again is the slope, is 0.15, and Nick, we found, is 0.10. Okay, so what does this mean? Well, rate of change is a something per something. So in this case, it's the cost per minute. So what does that mean? Vicky pays 15 cents per minute, and Nick pays 10 cents per minute. So to compare them, we can say Vicky pays more per minute than Nick. Okay? All right, last part here. How much will Vicky and Nick's cell phone bills be for 200 minutes? All right, so we're going to want to use both equations, Vicky versus Nick, and we're going to use both equations to figure this out. So Vicky's equation is y equals 0.15x plus 49. Nick's we figured out 0.10x plus 60. So minutes in this situation is x. So I'm going to plug in 200 for x in both of these equations, and that's going to tell me what the total cost is. So do that as my next step. In both equations, I'm replacing x with 200. Sorry guys, I must be getting some Amazon packages today. My Alexa keeps telling me. Alright, so let's type this in our calculator. 0.15 times 200 plus 49. So I'm getting that Vicky's bill is going to be $79. And if I type in Nick's, 0.10 times 200 plus 60, I'm getting that his bill is $80. Okay, so they're only $1 off for using the same amount of minutes. Alright guys, you're doing amazing. Let's move on to number 5 here. Lindsay and Becca each have a membership to a gym. Lindsay's membership is represented by the function y equals 3x plus 29, where x represents the hours with a trainer and y represents the cost. The cost of Becca's membership is shown in the graph. Okay, so we have two different memberships here. We have Lindsay's, which is represented by this equation, and we have Becca, who's in our graph over here. Okay, so it looks like we're comparing the cost versus the hours with a trainer. So let's go ahead and let's write an equation to represent Becca's cost. Now I need the slope and the y-intercept to do that. And so to find my slope, I'm going to pick 2 points and I'm going to use my slope formula to do that. So I'm just going to pick the first 2 points, 0, 39, and 451. So when I plug that into my formula, I'm going to have 51 minus 39, that's my change in y, and then 4 minus 0 is my change in x. So 51 minus 49 gives me 12 over 4, which is 3. So I know that my slope of Becca's equation is 3. Now the y-intercept, thankfully, I can see right on the graph. It says that it's 39 because that's when x is 0. So I don't have to do any work there to figure that out. So if I put this together, the equation for Becca is y equals 3x plus 39. Alright, so let's compare their initial values. So looking at Lindsay's equation, her initial value, her b, is 29. And looking at Becca's, her initial value is 39. So what does that mean? It means that if they're using 0 hours with their trainer, they're paying $29 and $39. Okay, so it's almost as if that is their monthly membership fee without any training. Okay, so to compare them, we can say Becca pays a higher monthly membership fee. So Becca pays a higher membership fee. Okay, she pays $39 where Lindsay pays $29. Compare the rates of change. So again, Lindsay, her slope was 3, and Becca also had a slope of 3. So what does that mean? It means how much they're being charged per hour with their trainer. So they're both being charged the same amount. So I'm going to say both girls are charged $3 per hour for personal training, which is very inexpensive. Must be a student rate, employee rate. Okay, last part here. What will be the cost for Lindsay if she has 4 hours with a trainer? Okay, so all we care about is Lindsay right now, and her equation was, back up here, 3x plus 29. So ours is x, which means I'm going to put in 4 in place of x in my equation. So 3 times 4 plus 29 is $41. So for 4 hours with a trainer, she's paying for her initial membership fee plus another $12 in personal training, which is a total of $41. All right, guys, last example. Thanks for hanging in there. Jeremy needs to rent a truck to move some furniture. The cost to rent the truck from 2 different companies is shown in the table and the graph. Okay, so we're looking at 2 different companies here. We have Crosstown Movers and Ron's Rentals. And part A wants us to write an equation to represent each company. Okay, so let's look at Crosstown first. In order to write the equation for Crosstown, we need to first find the slope. Okay, so what I'm going to do is I'm going to use the 2 points that were given here, and I'm going to plug those into the slope formula. I'm going to actually start my work way up here because it looks like I'm kind of cramped for space. Okay, so my change in y, I'm going to say is 45 minus 35. My change in x is 30 minus 10, which gives me a slope of 10 over 20, and because we're talking money, I'm going to say that that's 0.5. Okay? To get my y-intercept, it's important that we prove that it is in fact 30. It looks like it's on 30, but we don't know that for sure. And so what I'd like you to do is use your y equals mx plus b formula, plug in one of the points and your slope, and solve for b. So I'm going to choose the point 1035. So 35 is the y coordinate. 0.5 was the slope I just got. The x coordinate of that point is 10, and I'm trying to solve for b. So 35 equals 0.5 times 10 would give me 5, sorry, wrong thing here. And so then when I go to solve for b, I have to subtract 5, which is 30. So perfect, just what we thought, but again, very important to prove that because it could have been 31, it could have been 29, it's really hard to see. So I am going to put for Crosstown Movers, and my equation is y equals 0.5x plus 30. And so now we have to do the same for Ron's Rentals. Here. So for Ron's Rentals, we have a table that we're looking at. And remember, to get the slope from a table, I can thankfully look for the change in y over the change in x. Okay, so we're using X as miles and Y as cost. I'm getting that right from the graph above. And so I'm going to say my change in Y looks like it's 25. And my change in X looks like it's 10. So my slope, again, is change in Y over change in X, or 25 over 10 in this case, which is 2.5. Okay, so I know my slope is 2.5. Now I need to get my y-intercept, and this is a case where I would say let's work backwards. If I'm trying to get to 0 on my x column here, all I need to do is go back one place, because if it was going up by 10, if I go back by 10, I automatically get to 0. And on the right, in my y column, if I was going up by 25, I go back by 25, and I get to 0. So my y-intercept for this table is 0. So the equation for Ron's rentals would be y equals 2.5x, and you can put the plus 0, but you don't need it. All right, so part B says compare the initial values. So for crosstown movers, my initial value was 30. For Ron's rentals, my initial value was 0. So what does that mean? It means that you are paying an upfront fee to rent the truck from Crosstown Movers, but you're not for Ron's rentals. So I'm going to say Crosstown Movers charges an initial fee of $30 to rent a truck, but Ron's rentals doesn't charge. I'm going to try and fit anything. Doesn't charge anything. Okay. Compare the rates of change. So crosstown movers had a rate of change, or a slope, of 0.5. And Ron's rentals had a slope of 2.5. So if I need to compare these, first of all, what does it mean? It means the cost per mile. Y per X, cost per mile. So what it means is that Ron's rentals is charging you $2.50 per mile, but Crosstown Movers is only charging you 50 cents per mile. So we can say Ron's rentals charges more per mile. There we go. All right, so our last part here, which company should he use if he wants to rent the truck for 40 miles? Okay, so we want to compare. Is Crosstown Movers better, or less expensive, I shouldn't say better, or is Ron's rentals less expensive? So I'm just going to rewrite my equations for both of these here, because that's what we're going to use to figure this out. Okay, so 40 miles is what we're looking at. Remember, miles is our x value, and so we're going to plug in 40 in both equations for x. Do that step first, my substitution step. Okay, so for Crosstown Movers, 0.5 times 40 plus 30 is $50. So for 40 miles, it's going to cost $50 if you go through Crosstown. If you go through Ron's rentals, 2.5 times 40 is $100. Wow, quite the difference. So which company should he use? Well, if he's going solely by cost, Crosstown is definitely less expensive. Okay, great job, guys.